This is specifically linear demand functions. We'll just kind of walk through it because this is what the math people last time were dealing with. And so I'm just going to show you, it's no more than really algebra 1. So the graph on the left for markers, we have a demand curve that's obviously curved. Now, in real life, that's what demand curves look like. They are curved. That's why they're called curves, because they generally are curved. We tend to draw them as straight lines because we can do some interesting things with them when we do them with straight lines. And we can show concepts with a straight line that we can use some math that's way easier than the math we would have to do if we were using the actual curved lines. So looking at that straight line demand curve, you learned in math that the formula for a straight line is y equals mx plus b. And in that formula, y was our dependent variable. It changed based on what was happening to x. So x became the independent variable. We usually know this value. M is the slope of the curve, which you remember your formula is simply the change in y divided by the change in x. B is the y-intercept. It's where it crosses the y-axis. In other words, when x is 0, where does it cross the y-axis? That's your formula in math, y equals mx plus b. Now, in math, that straight line could go through any of those quadrants. In economics, we're only in that top right quadrant. We're only in that quadrant. We're on the positive y-axis and the positive x-axis, because very, very rarely do we actually need to dip into the negative sides of those things. This y equals mx plus b, it's just convention. At a certain point, somebody decided that y would be the dependent variable and x would be the independent variable. I don't know who or when that ultimately became the convention that everybody started following, but they did. But there's no mathematical reason why you can't switch those two. There's really no mathematical reason. We have to change the way we think about it a little bit. X changes based on what happens to y. Y is the independent variable, but the slope still stays the same. Now, when it comes to b, we can't say that b is where it crosses the y-axis anymore. We would have to say it's the x-intercept. It's where it crosses the x-axis. If y is 0, where does this cross the x-axis? Because we're dealing with economics, we can change that y to a p. So instead of the y-axis, it's the price axis. We can also change that x to a quantity demanded. But notice that everything else keeps staying the same. So the quantity demanded equals the slope times the price plus this b, which is where it crosses the x-axis. I haven't quite got to the formula yet, but it's the same basic thing as what we had a minute ago. M was the slope, b was the x-intercept. I shouldn't have made it move like that because b is now the slope. Again, why they did it like that is because they simply wanted to go A, B, and C, D for supply. They wanted to do A and then B and then C and then D. But again, remember that those letters are just letters. They're just variables that mean something. So in this case, B is no longer the intercept. B is now the slope. A now represents the x-intercept. So quantity demanded equals the slope times the price plus the x-intercept. Because demand curves are always sloping downwards from the high point on the price axis to down closer and closer to 0, because it's sloping downwards, it's always a negative slope. So we can save a little bit by flipping the formula around, and that's how they get the formula. Quantity demanded equals A minus BP, okay? They get that formula by taking the linear function of any line, changing the variables a little bit, just naming them something different. And when they do that, this is the formula that they get. So something like this. So here's our demand curve for computers, and quantity demanded equals A minus BP. Now, what if that term changes? That's the question that I'm asking. and I want an answer. What will happen if that term changes based on everything I just said? First of all, we got to remember what is A. What does A represent?
A is the
x-intercept.
Okay, so say it's x-intercept. In economic terms, it's the quantity demanded when what happens?
when the price is 0.
Okay, it's the quantity demanded when price is 0. So on this curve right here, that demand curve is headed towards, it looks like 400, right?
Yeah.
So if we had this formula, we could say quantity demanded equals 400 minus BP. Now, I don't know what the slope is right now, and P is a variable, but I mean, it could be 2P or 3P. I don't know. But quantity demanded equals 400 minus 2P. That might be the formula for this. So what would happen if the A term changed? But we didn't say the slope changed because the A term is not slope. The B term is slope. The A term is the quantity demanded when the price is 0.
Mm-hmm.
So you're right that this line would cross at 300 if we changed it. Okay, so we're going to look at an example. So here is the quantity demanded equals 400 minus BP. What if that 400 changed? That's what would happen. Okay?
Oh.
It's a parallel shift. The steepness does not change because the B term does not change. Therefore, it's a parallel shift, in this case to the left, because we went from 400 down to 300. So 400 was where it was crossing the quantity demanded when the price was 0. Now the quantity demanded when the price is 0 is 300. And so therefore it's a leftward shift of that demand curve. If the A term went from 400 to 500, obviously it would shift the other direction. If we have the full formula, quantity demanded equals 400 minus 3P, what happens if the 3 changes? The slope would change. It wouldn't be a parallel shift anymore because at a price of 0, the quantity demanded would still be 400. Okay?
Yeah.
So if it changes from 3P to 2P or 3P to 4P, we would see that curve, it would be doing this. Okay, depending on whether or not it went from 3 to 4 or from 3 to 2. Okay, and so you got to realize it's gonna touch that quantity demanded axis, and in your notes you should draw that down to the 400 and let it touch that axis so that you can realize, well, when it changes from 3 to 4, you want to actually think about that. Which direction is it going to change? Is it going to become steeper or is it going to become more shallow? If you realize what the terms are doing and what they're showing, you can figure out so many things. Any questions for me? Any other questions?
Absolutely not.
Okay. All right. Well, thank you for that. Yeah, well, just trying to be upbeat and teach you guys stuff. I guess hope you have a good day.